Today, we're going to dive into a really fascinating academic paper from some researchers in Chittagong, Bangladesh. They asked a huge question. Can we build a smart home system that's actually better, cheaper, and more open than what the big tech companies are trying to sell us? Well, let's break down exactly how they pulled it off. I mean, think about it for a second. We're all promised this incredible future of seamless, automated living, right? A home that just knows what we need. But is that really what we're getting? This is the core question that kicked off their entire project. And yeah, this slide just nails that disconnect. On one side, you've got the glossy marketing promise. Everything is effortless. Everything just works. But on the other side, well, that's the reality for a lot of us. A frustrating mess of expensive gadgets, complicated setups, and, worst of all, being totally locked into one company's world. So let's really dig into that reality. Before they could build a solution, the researchers first had to clearly identify the biggest hurdles holding smart home tech back for everyone. And here's the landscape they mapped out. You've got the tech giants, Google, Apple, Amazon, creating these pricey walled gardens. Then you've got the do-it-yourself route with something like a Raspberry Pi, but as the paper points out, that can get inefficient and be a real pain to maintain. And hanging over all of it are two massive elephants in the room: cost and security. This is the challenge they set out to solve. Okay, so they knew the problem inside and out. The next step, designing their own solution from the ground up. And their goals were refreshingly simple. Make it optimized, make it secure, and maybe most important of all, make it affordable. The absolute heart of their project is this tiny little piece of hardware, the NodeMCU. Think of it as the brain of the whole operation. The paper explains they picked this over Raspberry Pi because it's more advanced, sips power, and has better security baked right in. Basically, it was the perfect foundation for the lean, mean system they wanted to create. And this is where that affordable part really comes to life. I mean, just look at this component breakdown from the paper. The brain of the whole thing, the NodeMCU, is only 451 taka. We're talking just a few US dollars. You can see how they carefully picked every single part to be both reliable and super cheap. Now, let's put that cost into perspective. The researchers say their final device, which can control 4 different things in your house, cost less than 2,000 taka to build. That's around 17 US dollars. Now compare that to a lot of smart plugs you can buy, which can cost close to that much just to control a single outlet. The value here is just massive. All right, so they've got their shopping list of parts, but having the right components is one thing. Putting them all together into a compact, reliable device, that's a whole different ballgame. Let's see how they went from a digital blueprint to a real, physical board. Before we peek at the designs, let's just simplify a key idea here. A printed circuit board, or PCB, is that green board you see inside pretty much any electronic gadget. And honestly, the best way to think of it is as a tiny, perfectly planned city map. But instead of for cars, it's for electricity, telling it exactly where it needs to go. And here is that city planning in action. Don't worry about reading all the tiny text on this page from the paper. Just look at the images. On the left, you've got the 2D schematic. That's the initial flat blueprint. Then, using special software, they turned that plan into the 3D model on the right. This let them see exactly how every little piece would fit together before they even thought about building it. Now, to cram all of this technology into a tiny box, they designed a clever double-layered circuit board. These images from the paper show you those intricate copper pathways, the roads for electricity, on both the top and the bottom layers. Every single line is routed with incredible precision to make the final device as small and efficient as possible. And here it is. After all that digital design, all that planning, this is the final product, the fully assembled control unit. All those components from that price list, the NodeMCU, the relays, the power supply, they're all right here on one single physical device ready to get to work. Okay, so the hardware is built. It's impressive, but it's pretty useless if you don't have a way to control it, right? So now let's flip over to the software side of things, how a person actually interacts with it. So to control their IoT box, the team built 2 different interfaces, which you can see here from the paper. There's a web dashboard you can pull up on any browser, and they also built a custom Android app for when you're on the move. Both of them let you turn your devices on and off, but they also let you check on things like the room temperature and humidity, thanks to the box's built-in sensor. So what actually happens when you want to turn on a lamp? Well, it's this super fast 4-step dance. 1, you tap a button on your app. 2, That command instantly shoots up to a server in the cloud. 3, the server pings the IoT box sitting in your home. And 4, the box flips a relay, which is just a tiny computer-controlled switch. And boom, your lamp turns on. It all happens in the blink of an eye. Now, this flowchart from the paper shows the technical guts of the system, and the secret sauce that makes it all so fast is Google Firebase. The absolute best way to think about Firebase is as the system's own personal, super efficient post office. Both your app and the website send their commands, like little letters, to Firebase. Firebase then instantly delivers that mail to the right address, the IoT box in your home, which then carries out the order. It's that real-time delivery that makes the whole system feel so responsive. So the design looks solid, the software is slick, but does the thing actually work? Does it do the job reliably out in the real world? This was the final, and you could say most important step for the researchers, to test their creation, and test it hard. And the results? Well, out of 100 commands they sent to the device, 93% were successful. And here's the data right from their tests to back that up. They ran 100 trials. In 93 of those, the command went through perfectly. Only 7 resulted in an error. For a prototype device built on a shoestring budget, a 93% success rate is a fantastic result. It's a really strong proof of concept. So when you step back and look at the whole thing, they pretty much nailed everything they set out to do. They concluded that they successfully built a system that's compact, secure, and fast. It can easily be integrated into a home to control appliances you already own, and it's all powered by that real-time cloud server. And that's why this research is so cool. This isn't just some clever university project. It's a blueprint. It's proof that there's another path forward for smart home tech. One that's more accessible, way more affordable, and isn't locked down by a handful of giant corporations. And it just leaves us with this really fascinating question to think about. What if the true future of the smart home isn't something you buy off a shelf at a big box store, but something you can build, customize, and truly own yourself? What would you create?